Live. Okay, so let's go back to Algebra 2. I like that. So it is Octubre 8, 2021. Okay, our objective today, we're going to factor two different ways. Today we're going to factor by grouping, factor
You skipped me again.
by, oh, I'm sorry. Factor by grouping. Okay, and we're also going to factor perfect cubes. And the perfect cubes is actually pretty easy because there's a formula, which is nice. There's less thinking when you get a formula. You just plug things in. Now, factor by grouping. If you see four terms, okay? And I see four terms. If you see four terms, then we're going to group them. Well, I'm going to put these two together and then these two together. So we do by grouping, okay? That's obviously supposed to be a 30, not a 30, that's supposed to be a 30. So when you see four terms, you pair them up. So when I pair them up, I'm going to look at the first pair together and the second pair together, okay? So first, let's look at the first pair together. So 2 days ago, we talked about common factoring, right? We talked about common factoring. So let me hide the second pair, and let's only look at the first pair. What do these first two pair have in common? A 2a squared. You see that? They both have a multiple of 2, and they both have at least a squared in common. So we can common factor out of 2a squared. Okay? Again, I'm ignoring the second part. Okay? Ignoring that. So if I take out a 2a squared, what would be left inside? A 6a plus 1. And we can always check it. 2a times 6a, yeah. 2a times 1, yeah. So it's correct. Now let's look at the second pair for a minute. And again, we're going to common factor. I'm going to ignore this for a second. What do these two have in common? They have a negative 5. They have a negative and a multiple of 5. They have a negative 5 in common. They both divide by negative 5. Ever see that? So then negative 5 goes into 36 times, so I guess 6a. And negative 5 goes into negative 5, positive 1, because the negative times the negative is positive, right? Now, this is a two-step factoring. So there's two steps because you can factor again. What I notice now is they both have a 6a plus 1 in common. You guys see that? So we're going to factor again because they both have a 6a plus 1 in common. So I'm going to write down what they have in common. What do they have in common? A parentheses, 6a plus 1. And only write it once because you'll find out what they have in common. And sometimes I'll cross that out so I don't get confused. But what do they have in common between these two? They have a parentheses, 6a plus 1 in common. What's left over is the 2a squared minus 5. That's it. Let's practice this because you probably haven't seen it, right? Example 2. 4 terms, right? 4 terms, so we group. Put the first 2 terms together and the second two terms together, okay? 4 terms, pair them up. Do them by grouping, okay? Now, if I look at the first group, I ask myself, what do they have in common? 3h squared. Yes, you guys hear that? They have a multiple of 3 and an h squared. Nice job. So 3h squared is correct. And if I take out a 3h squared, what would be left? 7h plus 6. Can you see that? 3 goes to 21 7 times. I took out 2 of the h's. 3 goes into 18. 6 times I took out 2 of the h's, okay? Now, let's look at the second group. What do they have in common? They do. How about a negative 5? Do you mind if we take out the negative also? Let's take out the negative 5 because it's going to help it look more like this, okay? So a negative 5 is correct. Well, 5 goes into 35 7 times. And 5 goes into 30 6 times, but negative with a negative makes a positive. What I'm trying to do really is make these the same. That's my goal. And I did. I really want to make these the same, and I did that. So then, okay, again, what I'm going to do is common factor. What do the two groups have in common? Yeah, they've got a parentheses 7h plus 6. So I take out what they have in common. And what's left over?
3h squared minus 5.
Yeah, that's it. What do you think? Show me real quick. Thumbs up, sideways. Okay. Okay, good. We're doing all right then. Now, sometimes, like in example 3, we might need to regroup. Does that make sense? Might want to regroup. I kind of might want to put, or I could leave it the way it is, but, huh? It'll work the way it is. Okay, Molly says keep it the way it is. You guys want to keep it the way it is? Okay. Let me put a 1 right here. All right. What do these two have in common? Okay, first two, what do they have in common? Do you see how I put the 1 there? That's going to help you. Okay, x is in common. You'll see why I put the x there. What's left over? 8x squared plus 1. Had to have the 1 there. Now you see why the 1 had to be there, right? Okay, cool. Now, what about the second group? What do they have in common? What do the second group have in common? Negative 8. They have a negative 8 in common. And what would be left over is 8 goes into 64. 8 times but negative makes positive 8x squared. 8 goes into 8 one time, but negative by negative makes a positive. You okay with that? See this works? And then we're going to common factor one more time. What do the two groups have in common? Well, a parentheses 8x squared plus 1. And what's left over is just x minus 8. Okay, what do you see? You guys get it? You understand? So, before I turn the page, 4 terms. 4 terms, pair them up. Does that make sense? See 4 terms, group them. I'll say it again. You see 4 terms, group them. You have to factor twice, but I think you get it, don't you? Okay, 4 terms, group it. Okay, now turn the page. Perfect cubes. So if you have a cube plus a cube, it has a formula. I like that. It's got an actual formula that all we have to do is just plug it into the formula. That's awesome. And of course, a variation of that is if you have a cube, subtract a cube. It's almost the same equation. It's just a variation because of the subtract. If you got an equation, just plug it in the equation. Well, this is pretty nice. But first of all, before we do anything, what is a cube? What is a cube? Well, what's 1 times 1 times 1? It's 2 times 2 times 2. What's 3 times 3 times 3? What's 4 times 4 times 4? What's 4 times 4 times 4? 64. Yeah, I'm having a good day. All right, I'm having a good day. So let's list our cubes, our perfect cubes. 1 is a perfect cube because it is the same thing as 1 times 1 times 1, okay? 8 is a perfect cube because it's 2 cubed, right? 27 is a perfect cube because it's 3 cubed, right? 64 is a perfect cube because it's 4 times 4 times 4. 125 is a perfect cube because it's 5 times 5 times 5, and we really only need 1. 216 is a perfect cube because it's 6 times 6 times 6. So there's my perfect cubes, okay? Oh, yeah, thank you, Jacob. Nice, good catch. So if we had to factor example 4, I'm going to rewrite it. I'm going to rewrite it as x cubed plus 3 cubed. So I got a cubed plus a cubed, right? You can see that? And then, you see it. So then, I'm going to write this formula, because it's plus. I'm going to write a plus b times a squared minus ab plus b squared. But a is my x, and b is my 3, right? Okay, I'll let you catch up. And now it's easy, because all you do is plug x and 3 into your equation. Does that make sense? Okay, am I going too fast? Okay. Okay, so let's do it. So I'm going to go ahead and I'm going to put, right here, I'm going to put x's, 3's, I'll put x squared, I'll put an x and a 3 here, and I'll put a 3 squared here. So I'm going to rewrite this as, you ready? An x plus 3, because a is x and b is 3. I'm going to go in a squared, but x squared minus ab. A times b, that's going to be a 3x plus a b squared. Well, that's just 3 times 3, which is 9. Answer. Done. Done. Let's do example 5 so you guys really get the hang of this, okay? So 64, that's a perfect cube, isn't it? Do you guys see which one it is? 4 cubes. Let's rewrite this as a y cubed minus a 4 cubed, right? I'm going to use the other formula, the a minus b, a squared, plus ab plus b squared, right? I'm going to let my y be a and my 4 is b, and I'll just plug those in. I just take these values, plug them in. So instead of a minus b, it's just y minus 4, right? Just y and 4. Instead of a squared, it's going to be y squared, right? Plus ab, which is these two multiplied to each other. Ab is y and 4, or 4y. Plus b squared. Well, b is 4. What's 4 squared? 16. Done. That's it. Isn't that easy? There's no thinking. It's not like factoring. Sometimes factoring is hard because you have to think, right? You do puzzle. All you do on this one is just plug them in. Now, example 6 looks hard, but it's not. It's not. Is 8 a perfect cube? What is it? It's 2. So I'm going to rewrite this as a 2x cubed. See, I got both the x and the 2. So that's my a. And what's 27? 27 is a cube. What is that? That's going to be a 3y cubed. All right, it's plus. So I look at my formulas. I want to use that one because it's plus, right? There's the plus. I'm going to use that form. I'm going to use my a plus b, my a squared minus ab plus my b squared. And I'm just going to plug. So my a is going to be 2x, and my b is going to be 3y. There's my a, and there's my b, and I'm just going to take these values and plug them in, right? So instead of writing a plus b, let's write 2x plus 3y, okay? And instead of writing a squared, let's write 4x squared. You okay with 4x squared? You know how I got 4x squared? How do I get 4x squared? What's 2 times 2? Right. Minus 6xy. 6xy. See the 6xy? 6xy, because 2x times 3y, okay? And then plus 9y squared, because 3 times 3 is 9y squared, okay? And then that's it. Now if, and I'm almost done, what's really interesting, and I don't know if you care, but what's really interesting is if you were to multiply, right? That'll be an answer. Right? Just all the little inner stuff will cancel each other out, and that's what you got a formula for, okay? All right, so I have a worksheet for your homework, and then we're going to start looking at your journal on Monday, okay? I think we've got ourselves a pretty good spot.